A very good morning to Encik Afian and my friend. So today I will present my project report for the course MTES 3203. So as an intro, I will explain what is mathematical reasoning. Mathematical reasoning is the process of using logic and structured thinking to solve problems and justify solution. It's allowed learners to analyze relationship, identify pattern, and make sound conclusion based on evidence. Mathematical reasoning not only help in solving classroom problem but also in making real life decision. One effective non-routine problem solving strategy is the working backward method, which begins from the desired goal and trace step in reverse order to determine the starting condition. In this task, I apply the working backward strategy to a practical situation involving a farmer who wants to build a rectangular field beside a river using a fixed fencing budget. The purpose is to determine the integer dimension of the field that will produce the largest possible area, while ensuring that the entire budget of 400 ringgit Malaysia is used. This project follows Poya's 4-step problem-solving model, which consists of understanding problem, devising a plan, carry out the plan, and looking back. The report also demonstrates reasoning, creativity, and critical thinking skill. Now let's look at the problem statement. A farmer wants to build a rectangular field beside a straight river. There are only 3 sides involved, 2 widths and 1 length need fencing. The cost of fencing is 10 ringgit Malaysia per meter for the length and 5 ringgit Malaysia per meter for each width. The farmer has total budget of 400 ringgit Malaysia and the farmer want to use of it. The problem requires finding integer dimension, length, and width for the field that satisfy the cost condition and give the maximum possible area. The solution must be include clear reasoning and justification of mathematical step based on logical relationship. So now let's use the Poya problem solving module by using the working backward strategy. First step is understanding the problem. Based on the problem, we can get the information that the total fencing cost include 1 length and 2 width. So the cost relationship can be written as 10L plus 2 times 5W equal to 400. And L represent is length and W represent as width. And we can simplify the equation. We can get 10L plus 10W equal to 400 and L plus W equal to 40. The area of the rectangular field is given by A equal to L times W, and we need to find the positive integer value of N that satisfy the cost equation and produce the largest possible area. Now we do step 2, which is devise a plan. In the working backward method, we start from a goal, which is the maximum area, and works in reverse to determine the condition that to lead it. Step in the plan. First one is begin from the final condition, which is the total fencing cost of 400 ringgit Malaysia, and express one variable in terms of the other using the cost constraint. 3 is substitute this expression into the area formula to find how area depends on one variable. And 4 is reason backward from the desired result, the largest possible area, to identify what relationship between and give that result. 5 is verify that this value meet all the problem condition. This strategy focus on logical deduction rather than random guessing, making it efficient and systematic. For devise a plan, we also need to explain why the possible integer value for the width with range from 1 to 39 is not need to test because it unnecessary to test each value one by one when we're using the working backward strategy. This is because the relationship between length and width can be determined algebraically from the cost equation. By analyzing the relationship, it becomes clear that when width is very small, the corresponding length becomes large, which produces a small area. As the same, when the length is very large, the width becomes small and the area again decreases. Therefore, the maximum area must occur when both sides are balanced and nearly equal. Prove this reasoning, we can directly deduct the maximum area happen when without needing to test all possible values. This demonstrates how the working backward method saves time, promote logical reasoning, and provide a more efficient solution compared to the guess and check approach. We start the carry out the plan from the cocoa toss, L plus W equal to 40, and we change the formula, we can get that L equal to 40 minus W. And we substitute this formula into the area formula, which is A equal to L times W. And we substitute in, we can get that A equal to W bracket for 40 minus W. This shows that the area depends only the value of width. And now we reason backward from what we know about the product of two numbers, which is when two numbers have a fixed sum, their product is largest when the numbers are equal. Therefore, we can conclude that L equal to W. So we can substitute the L equal to W situation into the cost equation. So for the cost equation is L plus W equal to 40, and substitute L equal to W, we get 2W equal to 40, and divide it by 2, W equal to 20. Then we minus the value of W to get L, which is L equal to 40 minus 20 and L equal to 20. And we calculate the area, A equal to L times W, and substitute the value of L and W. We can get A equal to 400 meters square. And last, we need to verify the cost. The cost equal to 10L plus 10W. So we substitute the value of L and W we find, we can get that the cost is 400 ringgit Malaysia. Hence, the farmer should build a square field with a dimension and producing a maximum area of 400 meters square while using exactly 400 ringgit Malaysia. And now we do the last step, which is looking back. The working back strategy is highly effective in solving this problem because it began from the final goal using the full budget to achieve maximum area and work logically backward to identify the required condition. Unlike guess and check method, this approach avoid necessary trial and focus directly on the relationship between cost and area. Mathematically, the area is maximized when both sides of the rectangle are equal. This is because for a fixed sum, the product of two numbers is largest when the two numbers are the same. Thus, when the product area reach its highest value of 400 meters square. Through this process, I approve my ability to connect algebraic reason with real-life problem solving. It helped me understand that mathematical reasoning is not only about applying formula but also about thinking logically, testing relationship, and justifying conclusion. In addition, this task helped me develop several 21st century competencies as known as 6C: critical thinking, creativity, communication, collaboration, character, and citizenship. Critical thinking was shown through analyzing the mathematical relationship and reasoning backward from the outcome to determine the condition for the maximum area. Creativity was expressed in using a non-routine strategy that's focused on logic rather than trial and error. Communication skills were enhanced and as I learned to explain each mathematical step clearly and systematically in writing. Collaboration and character were developed through teamwork, persistence, and responsibility in ensuring accurate and organized solutions. Citizenship was reflected by connecting mathematical reasoning to a real-world agriculture situation that demonstrate the importance resource management and decision making in everyday life. This activity also strengthened my understanding that mathematics is not limited to theoretical learning but play a vital role in real-life application. The process of working backward encouraged me to think critically about the relationship between cost, length, and width, and to justify each decision logically. Through this experience, I learned that mathematical reasoning requires not only calculation but also explanation, reflection, and effective communication of ideas. This reflection shows how reasoning connects mathematical to practical and social context, fulfilling the goals of MTES 3203. In conclusion, by applying the working backward strategy, the farmer can maximize the area of the rectangular field beside the river by setting both the length and width to 20 meters. This creates a total area of 400 meters square while using the entire 400 ringgit Malaysia budget. The method proved logical and efficient because it starts from the end goal and work backward to find the condition that satisfy all constraints. This report also enhanced my understanding of mathematical reasoning as a tool of structured problem solving. It strengthened my critical and creative thinking and improved my ability to communicate mathematical ideas effectively. Furthermore, this project enhanced my appreciation of mathematics as a problem-solving tool that support logical decision-making in everyday contexts. The working backward strategy demonstrates how algebraic reasoning can simplify complex situations and lead to efficient solutions without unnecessary trial and error. By completing this task, I became more confident in applying structured reasoning to analyze problems, interpret relationships, and verify solutions. This skill will be valuable in my future study and professional life, where analytical thinking and clear communication are essential. Lastly, the working backward method not only provide in an elegant mathematical solution but also demonstrate the power of reasoning in real-life decision making for this course.